Thank you very much, Amna, and thank you also to the Flip Plus team for the invitation to present today. It's really a pleasure, not only to present, but to get some feedback from you on the ideas. So there's a user experience principle there somewhere. So my starting point really is for us to consider this huge digital transition that's occurring in educational assessment, the transition from paper to computer-based tests, and what a profound shift that represents for how we design educational assessments, how we validate them, and how we use the data. And so that process of design and validation introduces, I think, a fairly new idea to educational assessment, which is the centrality of user experience in the design and use of these assessments. With paper-based tests, we hear a lot about assessment validity, and of course design is important. There's a whole history there of design around paper-based tests. But when we get into computer-based tests, the challenges of good design are so much greater because we're dealing with much more complex interactive content. And so it's so important upstream to do that work on user experience, to check that people are going to be engaging with the test items in the way that we anticipate. So I'm going to talk a little bit about UX, and then I'm going to look at some examples. So first of all, then, what is user experience? In general terms, user experience investigates the response processes and perceptions of users as they engage with digital products. Of course, it can be wider than digital products, but I guess in this context, we're looking at digital products. And it concerns things like the navigation, but also people's beliefs and their knowledge, and themes like aesthetics. Now, these become much more important in computer-based testing. The aesthetic qualities, people's preferences and likes. It's much more important than it would be in paper-based tests. And also navigation is much more complex because very often people are interacting with the item in a way that you just couldn't with a paper-based test. So navigation and aesthetics become much more important. And user experience has cognitive and affective dimensions. So it's not just about the cognitive process, it's about how people engage with a test item, for example, but their affective response. How do they feel about it? How is it impacting on their engagement and their motivation? And it has physical or material aspects, and we deal with embodied and temporal dimensions in that assessment, for example, takes place in a particular place and time, and that particular place and time has consequences. So it's an iterative process to inform product design, but also to improve the reception and use of products with diverse populations. Now, clearly for assessment, that's quite significant. So it's not just the design of items, but for example, with the work of Flip, you might take an item which is designed in one context for one particular purpose, and you might decide to use it in another context. And so it becomes a user experience issue. We cannot assume that it will perform necessarily the same in different contexts from different groups. So how about then in user experience in computer-based assessment? I think there's a number of challenges. Obviously, a lot of opportunities, as you all know, of using computer-based tests. But from a UX point of view, there's a number of distinct challenges. And I just want to identify what I think are three quite important challenges. The first then is the challenge of construct representation. So when we do an assessment, we're trying to assess a particular construct or a trait, and we're trying to avoid construct irrelevant variation. In other words, threats to validity from something influencing the test scores, which isn't the thing that we're trying to assess. So in this case, for example, it might be that somebody's ability to understand the design of a test or to navigate the test might impact on their ability to complete the item, or, for example, on their motivation and engagement. So we're trying to, with good user experience, we're trying to avoid constructive irrelevant variation. The second point then is that we have challenges of accessibility, inclusion, and user experience across diverse users. So that raises questions about fairness and reliability. So when we design a test item, a computer-based test item, we have to not only think about how it's going to work with an individual user, but the kind of diversity that might be present in the population that we want to assess. And we might be looking at, for example, cultural diversity, we might be looking at disability, and of course, we're looking at a range of abilities. The third point is the challenge of item parameters. So we've got three key themes here that we need to anticipate when we do think about user experience in test design, which is somewhat different from general user experience, for example, in web design, etc. Because in computer-based tests, some of the test takers must not succeed on an item. The task of assessment is to differentiate between people who can get the test right and the people who can't. So we need to make sure, for example, that the difficulty of the test is not the result of user experience or design issues, but is genuinely issues relating to the construct or task or trait that we're trying to assess. And we want a very clear discrimination between people who can and cannot do this particular item. And thirdly, we need to think about guessing. How does the design of the item encourage or discourage guessing, and how do we know when people are guessing? So some of the test takers must not succeed in each item. So we need to make sure that they're not succeeding if they don't for the right reasons, but also if they don't succeed in the item, that it doesn't put them off. It doesn't upset people by not succeeding on a particular item. So there are quite big challenges there when we're doing looking at UX and computer-based assessments. There's potential for unintended negative consequences to impact on people's beliefs about themselves, about their own ability, and their beliefs about the topic. So we don't want, for example, as a result of, for example, bad UX design, to make people lose their confidence, or to lose their confidence or their interest in a particular topic. But perhaps also important for many of you, we don't want them to have negative perceptions about particular assessment products or assessment providers as a result of bad design. We need to make sure that they're happy, they feel confident, that they feel that the assessment is good assessment, that it's valid and reliable, etc. So I thought I would start by looking at this test item. It's an item which is made available publicly by the OECD as an example science test question from PISA 2015. It's available on freely on the internet. There's a web URL there. I thought it was quite an interesting place to start because it shows a typical kind of design of a computer-based test. I just want to tease out one or two issues there. This being an OECD assessment, it tends to be presented in a particular way. And in this case, you've got some instructions on the left. You've got some images. It's kind of multimodal. It's got pictures, diagrams. But it also has some dynamic content, which obviously a paper-based test would not have. So they're able to use the slider in the middle to do a data trial, and then to create data that is added to the table. So you've got quite a complex interactive situation, and it might not immediately be clear to the test taker which order they take they look at the content, where are the key instructions, which information is most important, etc. And similarly, they have to get to know the icons and symbols, the instructions on the item. For example, the go forward button and the go back button and the question mark, etc. And then the last point here I thought was quite an interesting one, is that when you provide some information, in this case, it's providing feedback. It says good, it's encouraging. And I think one of the things that obviously a computer-based test can do is provide feedback immediately to the test taker. It can provide encouragement and also some support, for example, with navigation. So in this case, it's saying, please click onto the next arrow to continue. So this gives an idea of the complexity of a typical computer-based test, and why it's really important that we do good UX work, so we understand how are people engaging with these items, how are they navigating, because the test designer will have particular ideas about what should happen, but the test taker might have quite a different experience. So just a little bit then about user experience methods. Typically, user experience methods involve various observational techniques, which include eye tracking, the use of video, and classroom observation. But they can also include cognitive interviews, so either think aloud or retrospective think aloud, where you encourage the respondent or test taker to talk about their experience, to share their views about it and how they're engaging with the item, how they feel about it. And in the case of computer-based testing, it can enable you to get feedback about platform design, about the test and how people engage with the test, and also to drill down to item level user experience observations. So we can get with computer-based testing, we can get very precise and detailed information, not only about user experience in general, but right down at the level of an item. How are people engaging with particular items? Are they, for example, reading the instructions and the content of the item in the way that people anticipate? And the last point there, it's important to think about when you're doing UX work, who are the appropriate groups? Who is this assessment designed for, and who are going to be involved in taking this test? And to actually do user experience work with those groups, and also in the ecology of the testing situation. In other words, to do UX work in the wild. In my experience, very often test designers have a habit of taking test items home to test them with their children, which might be useful and kind of interesting as a first kind of thing to do, but actually it can be quite a unreliable thing, because first of all, it's a very small sample, but also the children of test takers are not necessarily representative of the kind of diversity that we would actually see in a school or a testing center. So that's a selection of the test taking groups and the context of the testing situation are actually really important. Okay, so now I'm going to go into a bit more depth to look at a particular test item, and I'm going to give an example of 3 respondents and look at how they engage with this particular test item. And this work is from a collaboration I have with DEP at the Ministry of Education in France. The DEP team are here on the call, on the webinar, and they might want to add comments later as we go through the discussion. But this item is called the carpenter. And it's a very interesting item. It's very dynamic as a technology enhanced item. It's an interactive item. And the question there at the beginning, the scenario is that there's a carpenter who makes stools with 3 legs, chairs with 4 legs. And the puzzle, the mathematical puzzle, is that he made 35 objects with 19 feet. And the question is, how many stools and chairs did he make? So what I've done just now is I've created little boxes around different parts of the item where it says AOI 1. So AOI is an area of interest. So in eye tracking software, people tend to create areas of interest because that enables you to collect data about how often people look at that particular area of interest. And you can collect data around, for example, the frequency that people look at it, how long they look at it, the order in which people attend to various content in the item. And it's surprising, actually, that when you look at that kind of data, you find very often that test takers do not engage with the item in the way that was intended. In fact, very often they might entirely miss the instructions and then only come back to the instructions later, or perhaps not even at all. So it's so important to check how are people actually engaging with the item. So I've created a number of AOIs, areas of interest. At the top, we have a description, and then we have the instructions. AOI 3 is a set of digital tools. And we not only look at when people are looking at those tools, but how they use those digital tools and whether they use those digital tools. And in my experience, digital tool design is perhaps an area that is really quite difficult. If you take something, for example, like a compass or a ruler, to make the transformation from physical tool to a digital tool is not a straightforward process. And my experience, people sometimes don't engage with digital tools, not because they don't want to use the tool, but because they don't feel comfortable using the tool. And in fact, we'll look at that in a moment. AOI 4 is a slider. So there's some really, really cool interactive dynamic content in this particular item. So in order to find the answer to the question, they're able to use the slider and move the slider and then press the button AOI 6, and then it creates, it populates the table AOI 5, the results table. Now, a number of things about this item which are interesting. There are various ways to get the correct answer. In fact, also various ways to get the incorrect answer. The participants can use a slider and they can do trial and error with the slider. Or if they have more sophisticated mathematical skills, they can actually use algebra to work out the answer. And just as an aside here, DEP collects process data, log data from its respondents. But for this particular item, there are a number of questions about the process data and how it's interpreted. And so we've used, in this case, we've used user experience data such as eye tracking to help inform the model building and the interpretation of the process data. And in this particular item, we found there was a clustering of response times. In other words, people who got the answer correct and people who got the answer incorrect tended to take about the same amount of time to complete the item. So it's a good example of the fact that, for example, sometimes guessing does not happen rapidly. There's a big literature in process data around rapid guessing. And people can use log data to identify guessing. But in my experience, quite a lot of guesswork happens as engaged test item taking. So guessing is not always a feature of disengaged test taking, but it can actually be a feature of test taking, of engaged test taking. And when it is, it doesn't have to happen quickly. So in this case, the UX data was necessary to really dig a bit deeper into test taking. So I'm going to show this animation briefly. This gives an example of how somebody might answer this question using the slider. So it's generating some answers, and then they make a modification and try again, and one more time. And you can see this is a kind of iterative process. This is the one strategy they might use as an iterative process to try to get the answer. So they're getting closer, and now they're just making a small incremental change. And then they get the answer, and then they write the answer in the box. There we are. So that's how the test designers imagine this should work. To some extent, it does work like that. But what's really exciting is when you start to do user experience work, you get a bit more detail of how people are engaging. So I'm going to present information here on 3 test takers very briefly, and how they've actually engaged with this item. So participant 1 is a really smart girl. She uses pen and paper. She's really good at maths, so she uses algebra to work out the answer. So I'll just take you through the steps of how she engaged with this particular item. So you can see on the top left there's the image of the item with these green blobs, and these are points of fixation. So this is moments where she's looked and stopped and looked at for some time at some of the content, and the eye tracking software creates individual fixation points when they look at particular content as they engage with it. And the green lines, which you might not be able to see there, but there are lines between them which shows the scan paths, which can indicate the order in which people look at certain content, and we can work out how long, etc. So she begins by really very carefully reading the instructions for quite a long time, but also to look at some of the detail on the item. And then she goes to step 2, which is exploring the item and the slider. So she quickly and very carefully looks at all the content, and this is beautiful from the point of view of the test designer. This is exactly what they might be expecting. But then she does something else, which actually she leaves the computer behind, and at that stage we don't get any click data. So we're dealing with something that's happening between the clicks, but we also get a huge gap in the eye tracking data. So what's going on? What's going on here is that she's using pen and paper, and she's using algebra with occasional looks back at the item just to check on the content as she's doing this algebraic calculation. So is this a UX issue? Well, it might be a UX issue because in fact there are tools, digital tools on the item that somebody could in theory use to do an algebraic calculation. But this girl feels happier to use pen and paper. Now, there's a number of questions that raises about whether it's to do with the digital design, that she prefers to use pen and paper than the digital tools, or whether it's just a normal thing in classrooms that people tend to use pen and paper when they're doing algebra. So she feels happier. But interestingly, the test item does not say in its instructions, you may use pen and paper. So it's kind of interesting that she feels perhaps confident enough to use the pen and paper to do the calculation. But it's really quite significant, because if you were using log data, for example, to look at the response processes, the log data would not capture this activity. It would have the only thing it would have would be a gap, some missing data, something that's going on that we can't explain with the log data. Then she uses the calculator, she tries out a couple of combinations, and she gets the correct answer. Smart girl. Okay, participant 2 uses the slider and also pen and paper. Now his is interesting because actually he spends more than 2 minutes initially not engaging with the item at all, after he's looked at the content, that is, but using pen and paper. So it's really quite a long time to spend not actually interacting with the keyboard or the mouse at all. So from a log data point of view, there's nothing for more than 2 minutes. So what's going on? Well, he's using pen and paper. He's not quite as skilled as the girl though, so he struggles a bit. And eventually he comes back and he discovers the slider function. So initially he didn't realize that the slider could move, or if he did, he didn't try it out. And in fact, he added tried out the numbers just by typing them directly into the box where you can see it says number 17. But then when he did find it out, he very rapidly tried out multiple solutions and also using a bit of pen and paper for note taking in this case, more than, I mean, there's a little bit of maths going on there, but largely it was a combination of the slider plus some note taking and some calculation, and he gets the answer. So there's a number of UX issues perhaps there. Maybe he didn't realize that the slider could move. And when he does discover it can move, he uses it extensively to get the answer. So participant 3, slightly different image here. The green and yellow there is a heat map, so it's a similar kind of thing to the scan paths and the fixation points. You can see that this person's looked at the instructions, but actually they haven't looked at the instructions for very long. And this respondent was a little bit less confident than the other two and a little bit less engaged. And she only read the instructions for about 10 seconds, which is, for this item, which is quite short, a short time. She explored multiple solutions with the slider, but she didn't use pen and paper. And I wonder whether, for example, with a bit of note taking, whether it would have helped her to use pen and paper. Some respondents used the note taking using the digital crayon on the screen, but this respondent didn't do that and didn't use pen and paper. Eventually, using the slider, she finds part of the answer. So she finds an answer that adds up to 35 objects, which she's asked to do, but it doesn't have 119 feet. So actually, she gets a bit puzzled at this stage. And this, for me, from a user experience point of view, is quite interesting. So she finds a discrepancy between the instructions and what she's actually found as a solution. And eventually she submits the incorrect answer. And there's a question there for me, is this a UX issue? So what's going on? So there's a number of possible explanations. One is that she lacks self-confidence. She knows it's not correct, but she just tries it anyway. So it's a kind of guessing in a way. She's aware that it's not correct, but she just does this, fills in an answer anyway. But it might be some other things. For example, maybe she thinks there's an error in the computer. Maybe she doesn't trust the computer because she says, well, actually, I've got the right number of objects, but it hasn't added up. And she hasn't realized that there could be different combinations. And obviously, she hasn't used pen and paper, and it might have actually helped her to do that. The item hasn't encouraged her. So, for example, it hasn't said something like, well, you're almost right, try another combination. And perhaps that's to do with the particular purposes of this item, perhaps the designers didn't want it to encourage people too much or provide the answers. But yeah, a number of quite interesting UX points. So just to finish up then, what are the insights that this provides? Well, first of all, with the digital transition, with the move to computer-based testing, I think what it shows is that user experience studies provide essential information for computer-based testing, design, and validation. That the data can be used to improve test quality, to identify and remove sources of construct-irrelevant variation. In other words, how design might be influencing the outcomes in ways that we don't want. And also it might help us to avoid negative consequences. Because if people have a bad experience with an item, that will reflect badly perhaps on their own confidence with the subject, but also with the test provider. And finally, it helps us to understand the experience and engagement and perceptions of diverse groups of test users. So in the three examples I showed you, we actually have different levels of ability. And what's clear is that those raise slightly different user experience issues each time. So the very capable girl in example 1 felt very comfortable using pen and paper. But the respondent at the end, the third one, didn't use pen and paper when it actually might have been quite useful for her to do that. And we can also think about other sources of diversity, for example, the ethnicity of the users, the gender, and also neurodiversity and disability. How are, for example, disabled groups engaging with these items? Are they able to engage with them in the same kinds of ways? Just to finish off then, I mentioned the DEP team at the Ministry of Education in France. They've published this very nice paper a little plug for it in large-scale assessments in education that talks about the kind of data analysis that they do on the French items. Thank you very much.